So yeah, I'm very, very happy to present here on behalf of our entire consortium, the ICEBERG Project. So ICEBERG stands for Innovative Community Engagement for Building Effective Resilience and Arctic Ocean Pollution Control Governance in the context of climate change. So it's a project that runs for 3.5 years. We started in 2024 and we will go still till 2027. It's funded by the EU Commission under the European Horizon Program and under the call of clean environment and zero pollution. Yeah, and first, why we want to do the project, what is it all about? The motivation behind the project is that climate change and, of course, human activities release pollutants such as plastic, heavy metal, but also chemical contaminants into the ocean. And the Arctic is a very sensible region to pollutants, not only because it is warming up more than twice as fast as the global rate, but also because it relieves pollutants from the local sources, but also from long-range transportation of pollutants that end up in the Arctic due to the currents. And of course, these pollutants don't remain isolated. They travel through the water to the ecosystems, and they accumulate in the food web. You can think of fish species and then others. And ultimately, they affect also human health. And so that's why we have two main objectives in this project. First, we want to monitor and assess the sources and the types of distribution of pollutants. So where do they come from? What kinds of pollutants do we see? And of course, what is their impact on the ecosystem on the one hand, but also on the communities. And second objective is to work very closely with Arctic communities to monitoring pollutants together, but also to develop strategies for higher and foster community resilience and also adaptation at the local level on the one hand, but then also to influence global, or at least Arctic policy recommendations. And this at the Arctic level, at the global level, but also at the national level. Yeah, where do we work in this project? We work in 3 areas. We work in Svalbard. Why Svalbard? Because it is situated in the Arctic Ocean and is natural hotspots for pollutants that accumulate there due to the ocean currents. And they accumulate not only in inhabited areas, but also in areas that are non-habited by people, so in uninhabited areas, mainly in the southern part of Svalbard. Then our next study region is northeastern Iceland. Northeastern Iceland has seen a very high increase in cruise tourism, so there's a lot of concerns in local communities regarding pollutants and pollution. And the third study region area is South Greenland. And in South Greenland, we also see that a lot of pollutants from higher marine traffic come to Greenland, but it's also interesting because it is situated between the North Atlantic Arctic Ocean and the Labrador Sea. So we can actually monitor what kind of pollutants come from the Northern Atlantic and Arctic Ocean and then continue in the Labrador Sea to eventually reach the Canadian East Coast. Yeah, so we track pollution together in this project, and we also aim at creating solutions together. And I will give you some examples of what we do. And of course, this all is connected and linked to the One Health framework. So one thing that we do together with local communities and citizen scientists is to actually monitor beach litter. And we do that with drones, and these drones are coupled to an AI system that has been developed and that automatically recognizes the different types of beach litter. And this will then lead to these automatic maps of hotspots of where litter is. So we do train citizen scientists in drone flights. So our volunteers become drone pilots. Then the communities or interested people in the community select the beaches that the community wishes to monitor, and then we fly the drones. And this is kind of the typical drone image that you see here. And then all those images are fed in automatically in these AI system that then maps the coastal litter. And that are the kind of maps that you see here on the right, that are the maps that are produced. And these are really kind of handy maps then also to inform local authorities in the municipalities, for example, to then have something that eases their strategies of, for example, planning a beach litter cleanup campaign, or to kind of find out which are the areas in our region that we have to pay close attention to in terms of protecting them or in terms of restoring them. Yeah, and we couple this drone-based litter monitoring with also litter monitoring where we use time-lapse cameras. So together again with local volunteers, citizen scientists, but also local NGOs, everyone who's interested from the community. We select beaches for monitoring and install a camera that takes a photo at a regular time. Could be every hour or even every 2 minutes or every 5 minutes. That is what we install on the beaches. And then our local citizen scientists regularly check the cameras and also collect all the data. And then together with the citizen scientists, we develop an AI tool that will segregate also automatically the litter and show like what kind of litter types we have. So it could be fishing gear or any other litter. We also use driftwood just to train the model. And we have here some results so far. So we have 14 cameras now in Iceland, one in Svalbard, and 2 are still to be installed in Greenland. They're about of doing it as we speak. And there is a lot of images, of course, generated by those cameras. And now we train the AI model. You can see here on the little video how it works. So this is just driftwood as an example. And the camera or the model is now detecting where the driftwood is coming onto the beach. And we also develop a model that can be installed by open source on every computer. So if any person from the community also wants to create their own time-lapse cameras AI model, then it is possible to do so. So it's also democratizing this technology and making it accessible for everyone. Yeah, and in parallel, we coupled this also with a monitoring that is linked to an online interactive mapping tool. So it's kind of a mapping platform, and every person who wants it could go and when someone sees litter, then it's just like you just take a photo with your smartphone, and then you can upload it onto the map. It could be any multimedia data, it could be photo or I don't know, a video, or just an audio file or text as well. And so for now we have a quite good amount of citizen entries, and these are photos like you can see here from community campaigns. So this is from South Greenland, where they had a beach cleanup, and people also shared some of their emotions that goes with the campaign, but also with seeing so much litter on their beaches. So it goes kind of beyond just like technical data. People also share relational data of how do they relate to the pollution and also to the community action. And it's very interesting to say that this community platform, monitoring platform, everybody has access to it. So also it becomes kind of a knowledge exchange platform. So people in Iceland are also looking what the communities in Greenland have monitored in terms of litter and vice versa. So it's becoming more of an exchange and mutual learning platform across communities, which is very, very interesting to see. And we also look, of course, at the link between food and health and pollution, and that is maybe the part of the project that interests you most. So we work closely with the communities in Iceland and Greenland to better understand the sanitary quality of the Arctic food chain and how it impacts human health by linking dietary habits and potential chemical hazards. So first we analyzed and characterized and tried to understand what are our dietary habits. So we did that by surveys in Iceland and in Greenland to better understand what people locally eat and also to understand the potential exposure risks of people in both in Iceland and in Greenland. And in parallel, we select also the contaminants of interest. So we selected over 130 chemicals that belong to 7 chemical classes. And these include both like the legacy pollutants, so that are present in the environment for a long time, but also the emerging pollutants that are now being recognized of concern. Then, based on the local eating habits, together with our citizen scientists, we select food samples, kind of in Iceland and Greenland, mostly fish samples, but also samples from sheep, from birds, from berries. And then those samples are sent to the laboratory. And this is just a snapshot for you because it's kind of very first preliminary results here. So it looks typical like this, what we analyze. So you have here the blue bars, which are the concentration, and then the yellow or orange dots as well that represent the number of compounds. And for now, these are really like very, very first preliminary ones. We can see that regarding the PFAS compounds, that at least in the Iceland case, where we analyzed now almost like 10% of the samples, the levels so far are within the legal EU limits. But if we look at the pesticides, then we analyzed 27 organochlorine pesticides, and there we see very high levels, especially in shark meat, but also in cod liver, in Arctic char, in mackerel oil as well. And for those who work also in the Arctic, this maybe Arctic char especially might sound familiar to you. Then what we can do is like we use the validated analytical methods, the ISO methods 17025, and this allows us to really clearly say that all the analysis work is underpinned by this validated analytical method. And with these methods, we are now establishing baseline data for all these occurrence level in the Arctic foods. And we see also some profiles, contamination profiles emerging. Clearly, pollutants are widespread, both legacy and emerging pollutants. And regarding the food chain grading, an important outcome is that seafood consistently shows so far higher contamination than terrestrial foods, which is really a key for understanding better exposure risks in Arctic communities. And these results inform directly also policy, including the Greenland's first food security plan, and also international restriction on harmful chemicals like the PFAS. So we are in constant dialogue with the Greenlandic authorities in order to support with our results the future food sufficiency plan and strategy for Greenland. Yeah, we study plastic pollution that is visible, as you had seen in the past slide, but we also are interested in studying plastic pollution that is invisible. And here I speak about nanoplastics. And we would like to know what is the impact on the human health by looking at the human digestive system, namely the gut system and also the liver system. So together with our citizen scientists, we collected weathered like old plastics from the beaches. Here you can see some photos from Akureyri, so northern Iceland. And then we, in the laboratory, synthesize those in order to obtain realistic nanoplastics. And those we then develop a model to study those nanoplastics and then apply them to the in vitro gut and liver cells to evaluate the toxicity of those plastics. And we recently published the results. This is a study done by our partner in RAE in France, and Melanie, you can see here on the photo, did this study, and she found that exposure to one of the PFAS, the PFOA, even very small exposure weakens the gut barrier. And this, of course, has an impact of the human health. So it's also an important finding. And we continued this research for the next years to come. So this is kind of a very preliminary finding also that I can share with you here. And with all this, we would like to really go into action and provide support for policy making, as I told in the beginning, at the national level, but also at international level and at the local level. So part of our members of the consortium, which is, of course, very, very large consortium, are taking part in the International Plastics Treaty and the negotiations as part of the Scientists Coalition. And those of you who followed the Plastic Treaty negotiation, well, the last one was last summer in Geneva. There was no result reached, so we are looking now into the next negotiation round of this treaty. So we will see how it goes, but we are here and take part in it to bring the evidence on the health impact from the pollution from nanoplastics and PFAS directly into these international discussions. We also, because this is a EU-funded project, so at the European level, we see some lessons learned already from the project that we hope to inform or that can be fed into implementing One Health into EU policies. So I put here 4 kind of key messages that we can see, namely one, that the Arctic is and should be recognized as a One Health Centennial region, because it is an early warning region, but especially for the long-range pollutant impacts. It could work and be very relevant for also EU frameworks and policies. Then the importance of integrating environmental, biological, and human health indicators. So when we speak about One Health and Health project like this, tackling One Health, and we think it's important to see it from a holistic perspective, so that interdisciplinarity is a key word here in projects, and not only that, but also transdisciplinarity. And this brings me to the third key message: the importance of embedding and taking into account local knowledge and indigenous knowledge as a core system. So moving from this One Health theoretical framework that is often very fragmented to a more relational One Health framework. That is, I think, a key message here, but we can see from our project, and I think it's important that also international policies take it up. Together with this goes a call for really strengthening community engagement and citizen science to work with local communities together when we are in One Health projects. So yeah, this is a snapshot of our project, we still have 1.5 years to run. So you're more than welcome to contact us if you are interested in continuing following us. We also, of course, have Facebook and Insta and a website. So be very welcome to visit us. And here are some of our emails. So if you're interested, then please reach out.